Hi, and welcome to this lesson on classifying triangles, the first lesson in chapter 4 of our textbook. Before, we talked about classifying and measuring angles, but now we're going to go ahead and look at what those angles make up, triangles, and then we're going to classify those triangles. So just some words we're going to look at: acute triangle, equiangular triangle, obtuse triangle, right triangle, equilateral triangle, isosceles triangle, scalene triangle. Some of those words are the top four, defining the triangle by their angle measures. The bottom three are defining the angle by their side measures. So look at the angle measure classifications. We've got the acute triangle. Notice we have three acute angles there, all of those measuring less than 90. A specific type, notice all three of this triangle are less than 90, but if they are all three acute and congruent, thus they'd have to be equal to 60, we have an equiangular triangle. If we have one obtuse angle, like this one here, which leads us to have two acutes, that's going to be an obtuse triangle. And the specific case of a right angle in your triangle is going to lead to a right triangle. So let's classify this triangle here as acute, equiangular, obtuse, or right. Well, we don't see a right angle. There's nothing that's 90. There's nothing greater than 90, so it can't be right or obtuse. So therefore, it has to be equiangular, since all three of those, even though they are acute, they are all equal. So let's classify this triangle. We have a 30, 20, and 130 degree angles. Notice that since one of those is greater than 90, we have an obtuse triangle here. So let's go ahead and see if you can classify this triangle that runs from ACD. So triangle ACD, and you can pause the video if you need to. And now I would like you to try and classify triangle ADE. Alright, in this example, we want to classify triangle XYZ as acute, equiangular, obtuse, or right. And explain our reasoning. We're given angle measures of 50 and 40 of this triangle XYW, and we're given angle measures 50 and 40 of YXZ. We also know this is 90, so YWZ is a right triangle. Because this is a linear pair, we know that this has to be 90 as well. So I'll just go ahead and draw that in. You know this also has to be 90. We might not need that information, but it's always good to have. So we care about the angles of X, Y, and Z. We know X is 50, we know Z is 40. What we really care about is angle Y. And since we have these two angles making it up, we have 40 and 50, you can see that this angle is actually 90 degrees, a right angle. So therefore, XYZ is a right triangle. So now go ahead and classify this triangle ACD. They didn't label your points, so I'll go ahead and do that for you. Alright, so let's look at, before we were classifying triangles by angles, now we're going to want to classify them by sides. So in the first case, we have three sides that are congruent. In the second case, we only have two sides that are congruent. In the third case, we have no sides that are congruent. So three congruent sides means equilateral. Only two congruent sides means we have isosceles. No congruent lines, we have a scalene triangle. So let's classify this triangle by its side. The truss shown is modeled for steel construction. Classify JMN, JKO, and OLN as equilateral isosceles or scalene. So JMN looks like it's got, it doesn't really look like it has any congruent sides actually. So we're going to call JMN scalene. JKO, it does not look like it has any congruent signs either, so we are going to say scalene for JKO. And finally, OLN looks pretty congruent, all three sides, so we're going to call that an equilateral triangle. If you want to verify, feel free to grab a ruler and measure those sides if you're not convinced. Same with this one. If you would like to grab a ruler to just make sure of your answer, feel free. But go ahead and give your answer to this question. Alright, so now we're looking at example 4 here. If point Y is the midpoint of line VX and WY is 3.0 units, so let's go ahead and just label that line segment, is VWY equilateral, isosceles, or scalene? Well, we have 4.5 and 3.0, so therefore we need to figure out what this whether this side here would match either of those two. Well, they give us that y is the midpoint of Vx. So we know that Vy has to equal Yx in measure. So if y is the midpoint, each side is exactly 1/2 of 8.4 units. So 8.4 divided by 2 is 4.2. So each of these two sides is 4.2. Because Vy, Yw, and Wv are all unequal, we can say that that triangle is scalene. So go ahead and test your knowledge and reasoning skills on this one. And now we're going to go ahead and look at this one involving algebra. We have sides labeled d plus 6, 4d minus 13, and 12 minus d. We want to find the measures of the sides of the isosceles triangle KLM with the base KL. So first of all, we're going to want to find d. We know that it's isosceles, so two of those sides have to be equal to one another. I think clearly, since d plus 6 is the base, clearly segment LM and KM are the two that are equal. So solve for d. We're going to set KM's measurement equal to LM's measurement. KM is 4d minus 13. That's equal to LM, which is 12 minus d. Let's go ahead and keep it positive. Add d to both sides and add 13 to both sides. We get 5d on the left is equal to 25. Divide both sides by 5. We get d is equal to 25 over 5, which is 5. That gives us d. We want to find the measure of each side, though. So KL is d plus 6, or 5 plus 6, which is 11. So KL is 11. We want to get KM, which is 4d minus 13. So 4 times 5 is 20, minus 13 is 7. And our angle LM, 12 minus d, is 12 minus 5. Or, as we would expect, KM and LM to be equal, it is also 7. So notice we didn't have to find the measure of one after we found the other, but it's just a nice little check to make sure our reasoning was correct. So go ahead and make sure you understand by trying this problem on your own. And that concludes the first lesson of our geometry chapter for classifying triangles. As always, if you have any questions, feel free to ask me, and have a nice day.